Hey, what's up everyone? Welcome back to Scratch Next Gen. Today we'll be looking at stacks. So, what basically are stacks and how to implement them into your applications? Well, you've come to the right video. So, without further ado, let's get started. So, stacks follow a strategy called FIFO, which basically means first in and first out. So, imagine you have a stack of blocks. Okay, imagine you have a stack of blocks like this. Now pause the video, think about for a moment and see what kind of operations can you do when stacking a bunch of blocks. So let me tell you. The first operation you can see is that we can place a block one top of another. But we cannot remove the block from any middle places. Otherwise, the tower you have created will fall over. You can only remove what is at the top. Okay. And the other operation you can see is that you can only see the topmost block. So these are the three things which are present in a stack. You can place a block which is referred as push. You can pop an item which is referred as pop, and you can see what's in the topmost item that is called peek. So in a nutshell, this is what a stack is. So this is what a stack basically is. You can push an item, you can check what's on the topmost block, and you can pop an item. And if you want to see how our stacks represented in an array, let's have a look at that. So just like blocks, let's create an array. This represents the leftmost item represents the bottommost block, while the rightmost side represents the item present at the top. As you can see, for the push operation, you can just do dot append, meaning you can append the array. Let's say we want to push 8, we can place 8 here. We want to push 9, we can push 9 here. We want to push 10, and so on. This is basically push. Now, if you want to see the topmost block which you have placed, also referred as the peek operation, you can just check what is the last item of that array. And for popping, you can just basically remove this item and save its value. Luckily, Python has a built-in operation for popping, so you don't need to first copy the value and then remove it. And so this is basically it. Let's implement this in a Python program. So let's start by creating a class. And first of all, let's make a constructor. So what is a major default value you'll need? Of course, it is the array. Let's initially set it to nothing. And now we'll proceed by creating the three functions: push, pop, and peek. Let's start by creating push. I'll name the value we need to push v. And we can just append v to the array we have created. Now we'll create peek. Here you just only want to return what is the last item of the array. And lastly, we'll create pop, where we will just re- remove and return the item we have removed at the end of the array. So yeah, this is basically it. Just a few lines of code and you have made your stack data structure. Now let's look at an example problem. Now let's look at a problem in which you can implement the stack data structure. So given a string containing only bracket open and bracket close characters, determine if it is balanced. By balanced, it means that the bracket closes perfectly like this, and each open bracket has a corresponding closed bracket. So let's look at the analogy on how we approach this problem. So you're given a string, let's say bracket open, bracket open, bracket close, bracket close, bracket open. Okay, as you can see, it is not balanced since this is an open bracket. We'll name it Q to avoid less confusion. Now computers are dumb, you know that. They cannot just like see it and then do the operations in the do the operations like humans do. You need to tell what specifically do. You need to write a program that exactly solves this problem. So we can to solve this problem, we can just create basically a stack data structure, and we can check is this an open bracket. If it is an open bracket, we can just add it to the stack. As you can see, this is also an open bracket. It also appends it to the stack. And now we have come to a closed bracket. Now when you see a closed bracket, you remove or actually pop the bracket from the stack. And as you can see, a closed bracket is also present here. Then you'll also pop this open bracket too. But in the end, as you can see here, we have an open bracket. The pointer I is of the length of Q. And this stack is not empty. As you can see, this is when we can say the pattern is not balanced, since the number of open brackets do not have the same equal number of closed brackets. Let's look at another example. Let's say you have open bracket, close, close, and open, close, open, close. Okay. So as always, we'll add the first item to the stack, and as you can see, this is a closed bracket. We need to pop the stack, and now when you come here, the stack is already empty. Thus, this means the number of closed brackets are not equal to the number of open brackets. Thus, it means it is not equal. So basically, there are two test cases. That the stack is not empty, even if you have checked the last item of the string Q. And the second test case is another closed bracket appears even though our stack is empty. So these are the two these are the two things you need to implement in the program to basically solve this problem. So let's implement it. So firstly, we need to add another function to check is the stack empty or not. So we'll just type in empty, and if self.err, meaning it's not empty, will return false. Else will return true, meaning it is empty. Now let's create our function, valid parentheses, and here we'll type our string q. Now let's iterate through each character of our string. For ch in q, and also let's declare an object stack. Now for each character we need to append the stack if it is an open bracket. Otherwise we will pop the stack. Otherwise we will check if the stack is empty. Then we can just basically return false, meaning the parentheses are not valid. And if our stack is not empty, we can just do stack.pop. Lastly, if the stack is still not empty at the end of the loop, we can just do if stack dot empty. If it is empty, we can just return true. Else we have to return false, meaning the stack is not empty after we have checked the whole array. So yeah, this is basically a function. Let's run it on some test cases. Now let's test our program. As you can see, this test case is valid since you can see open bracket, the bracket closes, and then open bracket, and another bracket closes. So as expected, it returns true. And here, since it is not balanced, it returns false. So yeah, basically this is what we call a stack, and that is basically it for the video. If you like this video and find it helpful, please like and subscribe, and thank you for watching.